So I wanted to go through your digital conversion lab. You get this diagram, and you have to make up a truth table. You also have an HMI, which I'll go through in a minute. You have two sensor inputs. You also have separately a start and stop button and a system off. This is an output. So if you push the start button, you want to put in a start-stop circuit, and the output would be system variable. And when you start it and you have holding contacts across your start button, this light will come on. This will enable the machine. So let's look at the logic. This is a NOR gate. This is an inverter. And this is an AND. So the conveyor will run when an object passes sensor A. This will become true. Up until that time, the output is 0 because everything is 0. So it's an OR. This input goes high, feeds into the NAND. Sensor B is like a stop button. It's inverted, so it can be like a normally open or normally enclosed, and this is the inverter. So if the stop button is not pushed, that gets inverted into a 1. So initially you have a 1 here, and you have a 0 here. You push the sensor A button is energized. This is a 1, this is now a 1. The output is energized. This feeds back to the OR and stays on. So now the output is on. This is a 1, this is a 1, and the conveyor runs until the object passes sensor B. This goes to a 1, gets inverted to a 0. You put a 0 into an AND, it turns off. That makes this a 0, and this sensor is no longer activated, so you get two zeros. This becomes a 0, and the AND turns off, and the conveyor turns off. So that should get you started on that conversion lab. It is Boolean. Some of the early PLCs, you had to program them in Boolean, and you would actually type in sensor A or this output into an AND, which would be sensor not sensor B, and not this input, or and this input would then control the logic. So that lets you know how to sort of get started on this logic. So let's take a look at the HMI. Up here, you have your program, POUs, programs, program 0, section 0, and you can see your program. Here is the configuration and setup. Here is your I/O map. You can expand that. Now, I haven't done that because I'm not hooked up to a controller, but it would then list your inputs and outputs, and you can map your variables. If we want to look at the HMI, you go to the drop down here. The HMI has been created and added, so now we can go and look at the HMI, and it can be configured. You would have to give it an IP address, which is going to be in here under TCP/IP, and your HMI will be given an address. This is the one you're going to get in your lab as the base file. So it is already addressed. Now let's look at the program that's inside it. So HMI, you go to Pages, page 0. This is dynamic. So if I press Start, what this really is I can click on that, make it active, right-click, select the properties, and it will tell me all about that. We're calling that one button 2. It's a momentary button, which means it's going to be pushed and released. You can define the shape. You can put text on it when the button is not pushed. You can change the text when the button is down to say start pushed, whatever you want. You can change the font size in it. Every button has a variable linked to it. So this button is going to be called start_PB. And here we can see it's defined in the PLC. It will be defined as a global variable, start_PB. So now if you use start_PB in your program, your ladder logic, when this button is pushed, the HMI sends a signal to the PLC, hey, somebody pushed start, and then that closes the button in your program. This data type is Boolean, and I'm just going to slide this down a bit so we can see more of it. Close this window, and I'll go back up and expand that. Nope, gotta do it again. Takes a bit of juggling sometimes. And I expand it, and you can check the link to the PLC. You can map it to the controller. So here is the HMI. It's got a variable called PB. I can map that to a specific controller, a PLC. I can map it to a specific variable that you're using in your PLC program. Data type, and you can say add or update this variable. And that will check the link to the PLC. This is also under configuration and setup, variable mapping. You go to your controller, you go to user variables, and it lists all the variables that are in the PLC. These are the variables in the PLC. These are the ones you want to link to the variables in the HMI. And there is our start PB linked to a variable in the PLC called start_PB. So you can put any button on the HMI, link it to a variable in your PLC program, and then it will activate that variable. The only condition is if you have a start PB here, you cannot in the PLC IO map start PB to a real push button, because then the problem comes, because if you aren't pushing the real push button, it's set to a 0, and it will then disregard any signal coming from the HMI for start PB. Typically, you might want to prefix these or suffix these with an H to say, well, this is actually a button on the HMI. It's not a real button. And this may explain why when you put the same variable in your HMI, it doesn't work. The PLC doesn't see it, and you can push it, and it won't work. It's because the real push button is off. So they have to be separate names, and then it should work really well. The more you use these, the more comfortable you will get with these as well. So if I don't need that open, I can close that. There is our HMI screen. There are the HMI settings. I don't need that. There's the IO mapping for the PLC. Right now, nothing is hardwired. You could actually run your entire program from the HMI and not have any real push buttons or lights. Here is an output. Right-click, Properties. It's a bit lamp, which means it's off or on. You can change the shape, you can change the text on it, you can change the color. You can make the color when it's off, it's gray. When that output is energized, you can say, turn it lime green. You can change the color, whether it's a solid color or a gradation going through it, change the border thickness, and the expression is the variable that it's tied to in the PLC. So in the case of an output, it goes to the PLC, reads the variable conveyor, and then updates the HMI screen if that variable is off or on. So it's just a link, And it's very nice because you don't have to wire in buttons or anything else. Now, in reality, of course, you're always going to have a real start button, a real stop button. In case the HMI goes offline, you still have buttons to start or stop or e-stop the machine. In this case, system on is a variable called system_on. And if you really want to check that, you can look in the I/O mapping. Notice it's back to the controller because I've used one of the controller tabs. And that will be an internal variable. So if I go look at our program and I drop down variables and go to externals, there's conveyor. There's sensor B, sensor A. You can always make this longer to see your variables. There are the push buttons. So sensor A, sensor B, stop, push button, start, push button, system on, conveyor, and there is also an alarm light. So we can go back to page 0, but we don't have an alarm light on here, so we're not using that one. So it's a pretty simple concept. Don't overthink it. Basically, you're creating virtual push buttons, virtual inputs and outputs, and this communicates to the PLC and turns on inputs, turns off inputs, and reads the output states and displays them on the screen. So it makes it very easy and saves a lot of wiring. So in this case, for this program, you're not actually using any real push buttons. You don't have to do anything in the I/O map. It's all virtual devices on the HMI, but they function just the same. If you want to experiment, you can see that if you put that start_PB into I/O map and tie it to a button, the one in the HMI will stop working. Because now it's a fight between, does this one control that variable, or does the real push button control the variable? And usually the push button wins, because every scan, it will detect the push button is released, and the communication between the HMI is not going to be nearly as fast as the communication between the I/O push button on the PLC. There are other settings in the HMI, but the most important one is getting the Ethernet set correctly. The subnet mask just specifies that you're disregarding this and you're really only looking at that number for the address. There are other settings you can do, file transfers, VNC, remote control settings as well. You can flip back and forth between the PLC and the HMI just by using this drop down. Under the new controller, when you first go to configuration and setup, it should be configured like this. If you don't see this on your PLC, you right-click on Master, and you would go Compare and Merge with actual network configuration. This is grayed out right now because I'm offline and I don't have a PLC to go talk to. So since it can't communicate with a PLC right now, this is grayed out. If I was connected online, I could do that compare and merge, and then it would upload this, all the I/O modules. Now remember, EtherCAT is only used for the PLC to communicate with the input-output modules. And that's why you see this. So under controller, I/O map, it doesn't see much right now because I'm not working with a real PLC. So that will get you through week 8, and we'll go forward from that point on.